In this video, we're going to be factoring, and we're going to be factoring by finding what's called the greatest common factor, or GCF. In order for you to find the greatest common factor, you have to ask yourself two questions. Question number one, are all of the coefficients divisible by the same number? The coefficients are the numbers that are in front of the variables. So the first question is, are all of the coefficients divisible by the same number? And in this case, the answer is yes. 12, 8, and 16, they're all divisible by 4. They're divisible by 2, but we're looking for the greatest common factor. So we're looking for the biggest number that they're all divisible by. In this case, the largest number they're all divisible by is 4. So far, the GCF is 4. The second question you have to ask yourself is, do they all have the same variables in common? If we take a look at the x's right now, you'll notice we have x to the 5th power, x to the 4th power, and x to the 3rd power. They all have an x, and by they, I'm referring to the terms. Each term is separated by a plus or minus. So right here, this is one term, this is a second term, this is a third term. Okay, so all three terms have x's in common. What is the most amount of x's that I can take out from every single one of these terms? The most that I can take out is x to the 3rd power, because the first one has 5, the second one has 4, the third one has 3, so the third one can't give me 4 x's if it's only x cubed. So that means so far for this particular problem, the GCF is 4, because the largest number they're all divisible by is 4, and so far x cubed. We're going to continue by looking at the y's. They all have y's, y cubed, y, and y squared. What's the most amount of y's that I can take out from all of them evenly? And the answer is 1y. So the GCF for this problem is 4x cubed y. How do I factor by taking out the GCF? Well, now that I know that the GCF is 4x cubed y, I'm going to open a parenthesis and I'm going to go term by term. It used to be 12x to the 5th y cubed, but now I have taken out 4x cubed y. 12 divided by 4 is 3. I used to have x to the 5th power. Now I have x to the 3rd power, so the difference is x squared. It used to be y cubed. I took out 1y, so the difference is y squared. Then I move on to the next term. I bring down the minus. So I start again. 8 divided by 4 is 2. I used to have x to the 4th power. I took out x to the 3rd, so I'm left with x to the 1, which we really don't write the 1, but you know it's there. And then I used to have a y, but I took it out, so that means I am not going to bring down any more y's in the second term. So finally, I brought down the plus, and now I'm going to do the same thing. 16 divided by 4 is 4. I used to have x cubed. I took out x cubed, so that means I don't have to worry about bringing down any more x's. I used to have y squared, and I took out 1y, so that means I'm left with 1y. So the final answer, I'm going to finish my parentheses, and that's it. So the greatest common factor is 4x cubed y, and then if I want to factor, then I'm going to go ahead and divide. 12 by 4 is 3. X to the 5th divided by x to the 3rd. I subtract. 5 minus 3 is 2. I used to have a y cubed. I took out y to the 1 power. 3 minus 1 is 2. Because when you're dividing in the exponents, you really are subtracting. Then you keep going. 8 divided by 4 is 2. X to the 4th divided by x cubed. You subtract. 4 minus 3 is 1. And the y's just cancel. Plus 16 divided by 4 is 4. X cubed divided by x cubed. That just cancels the x's, and then y squared over y, that's just y to the 1 power. All right, so we're going to try some problems. Directions. Factor out the GCF from each polynomial. So we're going to find the GCF, and then we're actually going to factor the problem out. So in the first one, remember that we're asking ourselves two questions. Are all of the terms divisible by the same number? In this case, I don't see any coefficients. There are no numbers in front of the variables at all. Second question, do they all have the same variables in common? Right away, I can tell there's 4 terms, 1, 2, 3, 4. Every term is separated by a plus or minus. And I also can tell that every single term has x's. Every single term has y's. So that means that yes, I should have a GCF. So let's go ahead and find it. So what's the most amount of x's that we can take out here? X to the 7th, x to the 3rd, x to the 2nd, x to the 2nd. So that means that I'm going to take out x to the 2nd because at most I can take out 2 from all of them. From the y's, I have y to the 6th, y to the 2nd, y to the 5th, y to the 2nd. Again, the most that I can take out that all of them have is y to the 2nd. So that is the GCF right now. So the GCF is just x squared, y squared, because there are questions sometimes where they only ask you for the GCF. They don't really ask you to factor the whole problem. In this case, we are going to continue. We're going to open a parentheses and we are going to factor. So from the first term, I used to have x to the 7th, y to the 6th. I factored out x squared, y squared. The difference in the exponents is going to be x to the 5th power, y to the 4th power, because what we're doing is dividing, and when you divide, you subtract the powers. For the second term, you bring down the minus. So x to the 3rd, y to the 2nd, you subtract the exponents from what you factored out, the x squared, y squared. And so now we're going to have 3 minus 2 is 1, and then the 2 minus 2 is just 0. So that basically means I don't have to write any y's anymore. Plus x squared, y to the 5th. If I factored out x squared, y squared, again, the x's, there's no need for me to write any more x's. But the y to the 5th and then y to the 2nd, the difference in the exponents is 3 because I'm subtracting. And then something interesting is going to happen here in the last term. I have to obviously bring down the minus. Notice x squared, y squared is exactly what we factored out. And so because of that, we have to make sure that we're going to write down a 1 in our answer when we factor it, because it is very important for us to get back that term. And if we don't write down the 1 when we distribute to check to see if we actually did this correctly, we're never going to get back that term, x squared, y squared. And just to show you what I mean by distributing, we're going to take this final answer and now we're going to multiply everything out by using the distributive property. And this is a way for us to check to see if we actually did this correctly, or if possibly we missed a term, we made a simple mistake. So this is an easy way to check. So we're going to go ahead now and we're going to distribute. X squared times x to the 5th is x to the 7th. Y squared times y to the 4th is y to the 6th minus. Then we are left with x cubed, y squared, distribute again, plus x squared, y to the 5th, and then minus, because I'm multiplying by 1, I get back the x squared, y squared, which brings me back exactly to the original problem. So it's super important for you to put that 1, because otherwise you're never going to get that term back. In question number 2, we're going to do exactly the same thing. We're going to ask ourselves, are all of the coefficients divisible by the same number? And if they are, what's the biggest number they are all divisible by? In this case, the numbers are 2, 6, 4, and 8. And the largest number that they are all divisible by is the number 2. So 2 is going to become part of my GCF. Then I have to move on to the variables. Do they all have the same variables in common? They all have an A. They all have a B. So yes, A's and B's are going to become part of our GCF. Now we have to determine exactly how many. So the first term has a squared. There's an a here by itself, which is 1, a to the 1, a to the 4th. The most that I can take out in terms of the a's is a to the 1 power. For the b's, I have b to the 1, b to the 3rd, b to the 5th, and b to the 1. The most that I can take out from all of these is b to the 1. So that means that my GCF is 2ab. Let's go ahead and now factor the rest of the problem. So 2ab, open a parentheses. That means that from the first term, I need to write down a because 2 divided by 2 is just 1. And if I subtract the exponents from a, 2 minus 1 is 1, and then the b's would just totally cancel. If I go to the second term, 6ab cubed, and I divide, I'm left with, make sure you bring down the plus, 6 divided by 2 is 3, the a's would just basically cancel, and then I'm left with b squared. Go ahead and bring down the minus. So now 4 divided by 2 is 2. I used to have an a, so that's gone. And then 5 for the b minus 1 that I took out. I'm left with b to the 4th power. 8 divided by 2 is 4. I used to have a to the 4th power, but I took out one a, so I'm left with a to the 3rd. And then the b's will just cancel, so here is my final answer. Go ahead and see if you can do number 3 by yourself. So in question number 3, we're still starting with the same 2 questions. Question number 1, are all of the coefficients divisible by the same number? The coefficients I see so far are 5, 6, and 5. 5 is a prime number. It is only divisible by 1 and 5. 6 is divisible by 2, 3, 1, and 6. So right now, the 5 and the 6, they're not all divisible by the same number. So I'm not going to have a GCF that's going to have a number other than 1. So now we have to continue with the second part of the question, which is, do they all have the same variables in common? I do see m in every single one of the terms, and I also see n's in every single one of the terms. So yes, we are going to have m and n with some type of exponent perhaps as our GCF. So let's go ahead and figure out how many m's can we take out from all terms. The first one has 3, this one has 1, this one has 2. So the most that I can take out is going to be just 1m. Let's do the same thing with the n. Right here I have n to the 1 power, n to the 1 power, n to the 4th power. What's the most that I can take out from all of them? N to the 1 power. So the GCF is mn. I'm going to go ahead and factor. From the first term, I have to bring down the 5. I used to have m to the 3rd. I took out m to the 1, so I'm left with m squared, and the n's would cancel. Plus 6mn. So in this case, I would have to bring down the 6 because 6 divided by 1 is 6. And then the m and the n, they both actually would cancel out. So I keep going. The last one is 5m squared n to the 4th. So I'm left with plus 5m, because I used to have 2 of them, and I took out 1. N to the 3rd, because I used to have 4 of them, and I took 1 out. And that is going to be my final answer. Hopefully you got it right. Check yourself if you did. I'm very proud of you. Okay, let's go on now to question number 4. Same exact process. Question number 1, are all of the terms divisible by the same number? 5, 15, 10. Yes, they are all divisible by 5. Go ahead and take out the 5. Let's move on to the variables. Do they all have the same variables? X cubed, x squared, x. They all have an x, and I can go ahead and take out at most 1. Y, y, y. They all have a y, so I can go ahead and take out a y. So the GCF is 5xy. Let's go ahead and factor the problem now. This is equal to 5xy, open a parentheses. From the first term, 5 divided by 5 is just 1. X cubed over x. Basically, that's just going to give me x squared. The y's would cancel. Minus 15 divided by 5 is 3. X squared over x. Then you're left with the difference of 1. And the y's would cancel. Plus 10 divided by 5 is 2. The x's would cancel and the y's would cancel. And once again, we're going to distribute just so that you get the hang of checking to see if you are correct. If I distribute, I'm going to get 5x cubed y minus 15x squared y plus 10xy. And that brings me back exactly to the same original problem. So I'm confident that I did do this correctly. So then that means that yes, this right here is my factored answer. We are going to try 2 more problems. Take a look at question number 5. 28x cubed minus 7x squared plus 14x. Are they all divisible by the same number? The answer is yes. They're all divisible by 7. Do they all have the same variables in common? Yes, they all have x. The first term has x cubed, then x squared, then x to the 1. So that means I can take out at most 1x. So my GCF is 7x. Now let's go ahead and factor. This is going to equal 7x. 28 divided by 7 is 4. X cubed, but I took 1 out, so I'm left with the difference of x squared. Minus 7 divided by 7 is 1. You can write the 1 if you want, but right now we really don't have to because I am going to have an x here. X squared over x is just x. And when you hear me saying x squared over x, it's because technically what we're doing is dividing. So technically it's basically going 28x cubed minus 7x squared plus 14x, and we really are dividing by that GCF that we found out. And so that's why I tell you 28 divided by 7 is 4. X cubed over x to the 1, the difference is just x squared. Here the 7's cancel. X squared over x1 is just x. 14 divided by 7 is just 2, and the x's cancel. So that's why I'm telling you over, because basically what we're doing is dividing. So then for the last part, we have 14 divided by 7, which is plus 2. And then of course it already had an x, so I don't have to worry about writing anything down. I can get rid of the 1, and this is my final answer. Go ahead and see if you can figure out number 6 by yourself. Pause the video and then go ahead and put play. Okay, so in number 6, first question, are all of the coefficients divisible by the same number? The answer is no. I have 4, 7, 5, and 8. 5 is a prime number, 7 is a prime number. That means they're only divisible by 1 and itself. And so no, right now all of these numbers are not all divisible by the same number. So let's move on to the next question, which is, do they all have the same variables in common? X squared, x, there's no x in that problem. So right now x is not part of my GCF. Let's go ahead and check the y's. The first one doesn't even have a y. So this one has a y, this one has a y, but this one here has no y either. So there is no way that right now we're going to have a GCF at all. There's absolutely nothing that they all have in common. So there is no GCF. And right now it is not factorable because of the fact that we can't figure out a GCF. And because we really haven't learned any other types of factoring so far, in this video we're only focusing on GCF. So if you want to factor by finding the greatest common factor in number 6, there is none. So therefore, that's why I'm writing that it is not factorable. I really hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.